Bon après-midi, mesdames et messieurs. Buenas tardes, damas y caballeros. Good afternoon, ladies and gentlemen, and welcome to the International Civil Aviation Organization's 40th Assembly SkyTalks. My name is Sung-Hoon Kim, and I'll be your MC for this event. Over the course of 2 weeks, we have 68 presentations from aviation industry experts, with ranging from gender to big data, employment opportunities, drones, environment, and so on and so forth. I welcome you to go check the ICAO channel on YouTube for more information. Upon the completion of this presentation, I would also have you step up to the mic and ask questions to our presenter. We continue today's talk, which is day 5, session number 8. Today's talk is about big data, and we'll tell you about traffic forecasts and tools that ICAO provides. Our presenter today is Mr. Antonin Combe. Please welcome Antonin.
Thank you very much, and welcome to everybody in this room for our presentation about the ICAO traffic forecasts and tools. I'll be presenting the basic and the demonstration of the forecasting application and methodologies that ICAO has developed in the recent years. So to start, I'll tell you a bit about the genesis of those forecasts and the background information that has led to the creation and development of those traffic forecasts. So the purpose of the forecast is to serve the the FESG CAP, which is the Forecasting and Economic Analysis Support Group of the Committee on Aviation Environmental Protection. So by producing the forecast, then this forecast will be used for environmental assessment of the CAP work, and will support that work. Another purpose is also to produce ICAO Global Air Transport Outlook, to where we have the forecast presented in a booklet and also over an application that we will show you later. And lastly, the traffic forecasting groups, which are regional groups of experts comprising of various experts from the member states and also from the industry, where we produce forecasts at more detailed at the regional level. Why are we producing those forecasts, and is this a request by the Assembly? The last Assembly resolution was A3915, and it was adopted by the Assembly 3 years ago, which requested the Assembly requested the Council to develop and update forecasts of future trends and developments in civil aviation, then to ensure the availability of those forecasts to ICAO's member states and other aviation stakeholders. And the purpose, again, of those forecasts is to support also the needs in terms of safety, security, environment, air navigation, planning, etc. Another, in the resolution, it also says that the Assembly requests the Council to develop and update one single set of long-term traffic forecasts in order to ensure the consistency of all the forecasts that are produced and used in ICAO and by our member state. One recent outcome in relating to the forecasting activities has been the development of the single set of harmonized long-term forecasts, which has been presented during this assembly as working paper 20. So this paper highlights and presents the background information as well as the overall methodology that has been used to the forecast. And in appendix, you can find various tables with the expected traffic growth in terms of RPK by route group. And the forecasts are then derived to arrive at a personal level, fleet level and personal level forecast, which was the topic in the previous SkyTalk, which I invite you to listen to as well. I'm talking about the personal forecast in terms of needs of pilots, air traffic controllers, and aircraft engineers. Those forecasts were produced under the ADAP panel, which is the Aviation Data and Analysis panel, and this panel is composed of 34 states and 6 international organizations. And under this panel, there is a multidisciplinary working group on long-term traffic forecast called the MDWGLTF, established under ADAP. And this working group is working in collaboration with the Secretariat to develop one single set of long-term traffic forecasts. And based on this single set of long-term forecasts, we can then derive and customize and further customize those forecasts for the various needs of the organization, such as air navigation planning, safety analysis, environmental analysis, or the ASBU aviation system block upgrade implementation. And this working group is also using the models and is reviewing the methodology, the models, so it's a collaborative work to arrive at one single set of forecasts being used by the whole community in ICAO, our member states, and our industry partners. In this presentation, we will be talking about the various forecasts based on region pairs. So I wanted to share with you the regions that are being used in the forecasting tool and the forecasting documents. And to develop those forecasts, we have split the world into 10 ICAO long-term forecast regions. So those regions are different from the ICAO statistics region that you can find in our ICAO annual report or other presentations. So this is just to keep in mind that the world has been divided into these 10 long-term forecast regions based on the consensus of our group of experts. So we have grouped the countries based on similar socio-economic variables and also similar traffic growth and etc. Data sources. So to build our forecasts, our traffic forecasts, we have looked and collected the data in the past. For this, we have relied on the main source, which is our ICAO statistics program, and collected the data through the air transport reporting forms A, B, and C submitted by member states. So those forms contain the data of a number of flights, etc., at the airline level and also at the country pair and city pair level. We have also augmented the coverage and also to verify the data through other available sources. We have used the national offices of statistics from some states. For example, the US Department of Transportation is making those city pair data available on their website. And we have also used other states such as the UK CAA or the Bureau of Infrastructure, Transport and Regional Economics of Australia, which made data available that were used for our forecast. And at the end, we had a coverage of above 90% of traffic at a country pair level. OAG was also used to complement the data in some states or regions where the coverage was below that level of 90%. And at the end, we arrived at a very high coverage of 100% by using those various sources of data. Well, so the objective is to build and develop a long-term traffic forecast model. The collaboration is with the experts of the FESG of CAPE, and we work together to implement more sophisticated econometric forecasting methodology. And we were tasked to develop forecasts on a 3-year based projections to know the forecast of demand of air transport and for the next 30 years. And we looked at the RPK, the revenue passenger kilometers, as well as the RTK, revenue ton kilometers for the freight. And the different clusters options were, of course, to have an idea of the growth and trends at the global level, also at the regional level, the regions that I mentioned before, as well as the route group level, where we looked at the region pairs between the regions previously highlighted. So we had 10 domestic regions for domestic traffic and 40 international route groups. And also the next step was to develop a country pair level forecast, which is above 5,000 pairs. And for the freight, it is developed at the global level as well at the regional level for the 6 ICAO statistics regions, because the freight follows this usually is more east-west between North America, Europe, and Asia. So the flow of the freight is mostly east to west or west to east, instead of passenger flows, which are more sophisticated. So to build a model, we looked at the data and the various observations that we had. We had observations for the past 20 years, from 1995 to 2015. And we built the econometrics models based no longer on a time series, because this has some constraints and limitations, and to use the entire data set and resulting in more observations in total, we moved from a time series approach to a regression panel approach, where we built econometric models using panel regression analysis, which makes us using more observations, making the model more robust. So to have in mind the tree and the logic and the tree of the forecast buildings, at first we have the air traffic forecast that we divided into the passenger forecast and the cargo, and those passenger forecasts were further refined at a route group level, regional level, country level, and currently working at the airport level. The specification of our models. So first, the basic specification, and the idea is to capture the key economic drivers of air transport demand. So it is known that the air transport demand is basically, at a first approximation, a function of the income and cost of the air transport, as well as other considerations such as oil prices, etc., which are more difficult to know in the future. But we mostly looked at a model using income per capita and cost of travel using real GDP for building the model. The transportation maturity, meaning the level of maturity of the market, is also an important consideration to take into account in our models, because more mature markets will have a tendency to slower the growth after some time, like this is the S-curve effect. So to take into account this transportation maturity, we looked at, we classified the route groups into various tiers, ranging from low developed, low maturity to high maturity markets, in order to take into consideration this variation between the states. And for some year events such as the 9/11 or outbreaks such as SARS or Ebola, etc., where we used, of course, dummy variables for those years. These forecasts are available on an online application. It's an online ICAO web application. It is available on that website here that you see on the screen. And I invite all of you to take a look at our application, and also to leave a business card in the bowl at the back of the room, where we will give a free demo access to a lucky winner. And now let's take a look at the forecast application. So if you click on the air traffic module, you can see that we have forecast, cargo, and also historical traffic. But first, let's look at the passenger traffic forecast at the route group level or region level, for example. So in this drop-down menu, you can pick a region. Let's say Europe, and a country, a destination region. Let's take Asia, for example, and you select the forecast horizon in the next 15 years, and you can visualize the results about the past and projected available seat kilometers and revenue passenger kilometers performed between Europe on one hand and Asia on the other hand. You can also visualize the both number of passengers and number of flights both historical and forecasted by the models on one chart, as well as the historical and forecasted numbers are available with the number of passengers, number of flights, ASK, RPK, etc. So this is the air traffic at a region per level. You can further look at more details if you pick the route group at the route group level. At this route group level, let's select another one. So Europe to North America with a 25-year forecast horizon. And again, you can see on the application the historical available seat kilometers, revenue passenger kilometers, and the forecast compound average growth rate. And historical and projected numbers are also available in an Excel format if you wish. The application also enables you to select multiple route groups. So let's say you're interested in all the route groups departing from Middle East. So you click on Middle East, or you can select only a few of those if you're interested in Africa, Middle East, Europe, Middle East, and intra-Middle East. You select the time frame, let's say 20 years. And again, you can see on one single graph the three route groups that you have chosen, like Africa, Middle East, Europe, Middle East, and intra-Middle East. You can also add them or remove them from the chart. And look at the historical traffic and projected traffic, as well as the data. Let's look at the country traffic forecast. Now, if we look at the country level, you pick a country from this menu. Let's look, or you can select it from a map if you prefer. So this one is Poland, I think, to United Kingdom. So Poland to United Kingdom, or Poland to Germany. Looked at the horizon again, 20 years. And here you can visualize the historical traffic between the country pair as well as the projected traffic. And again, the historical data is fully available. The domestic, if you're interested in the domestic traffic of a particular country or region, you can pick a country like United States. And the tool will give you again the past and projected traffic for domestic in this country, for the United States. Country aggregated traffic. So this is an interesting module because this one will tell you all the traffic departing from one single country instead of a particular country pair or region pair. So again, you pick a country, for example, United Kingdom. You can look at international, domestic separately, or also both of them on one single chart. And here is the projection for domestic and international traffic departing from the United Kingdom. Another function is the airport traffic forecast, where you select an airport pair with an existing direct flight. So let's look at Montreal to London. And we know the historical traffic of this particular route because it has been reported, and you can see this on the screen here in terms of ASK RPK again for this particular route, and the number of passengers that have been transported on that one. Regarding the air cargo, we can pick the forecast by region and look at the projection in terms of cargo traffic for the airlines of that region. So here you see, for example, in North America, the historical and future projection for the domestic and international cargo, as well as the belly and dedicated cargo. The application also lets you choose a region of the air carriers, and you can select also different ones for comparison purposes or this. And here you can visualize this for 3 regions, for example. So thank you for that. You have a form on the application to contact us if you wish further information or you have any question regarding these forecasts and the availability or any question. Please let us know in this under the contact us menu. So I wish to thank you all for your attention for the demonstration of the forecast. Again, please leave us your card in the bowl in the back if you're interested in keeping in touch and winning a free demo access to our tool. And thanks again for your attention. Thank you.
Thank you, Antonin. If there are any questions, I would invite you to come up. Yes. Thank you.
Thank you. I want to find out what are the measures that you've put in place to ensure that the data that is provided by the states are properly validated or verified.
Thank you very much.
For completeness and also for accuracy. Thank you.
Thank you for your question. That's a very important question because data accuracy is, of course, at the very beginning of this whole process and forecast development. So we need to have accurate, reliable data at the beginning before building the models. So we have a verification system put in place so that we ensure that the data that is reported by the member states is accurate and reflects the performed traffic. So we have various steps. For example, we can compare the data with the data submitted by the same state the previous year to see if there is a big variation or no, or if we can explain. We can also compare the data with other sources, such as OAG, civil aviation websites, which is useful to detect like a mistake in terms of number of departures or capacity. And we also have now developed we have the ADS-B data that we record in live every day, and we can count the number of flights, for example, and ensure that the number of flights reported by the states is in line with what is actually performed and observed.
I believe this will be my final one.
Welcome.
I believe that if we also do have some commentary that informs the figures, it will also help so that, because figures in itself may not mean much, except for knowing how we got at these figures, so as to know whether in the presence of the factors that resulted in those figures, these same factors will be available. Let me just give an instance. If, for instance, there is a serious epidemic, it can affect the passenger numbers on a certain route. So in the absence of such an epidemic, then it means that the numbers again could go back to where they actually belong. In the same way, you talk about cargo. Sometimes certain states ban some export from certain countries, thereby affecting cargo in a certain direction or a certain type of volume in a certain direction. And if those embargoes are lifted, then we can really see the actuals or what is normal. So I don't know whether there's also that room to give some commentary that helps the figures in terms of their understanding. Thank you.
Thank you. So this is also an important question. You're absolutely correct, because if there is some political or economical reason that may dampen or the traffic growth in a particular state or region, then that's why we are using dummy variables to reflect what can happen in the past, to build a solid model based on that. But also, our model is revised also every year, because we incorporate new traffic that we observe and that we collect, as well as the new projection, new economic projection based on GDP, etc. So by revising the model every year, we take into account what are the changes in terms of the economic growth affecting the states and the regions. So by keeping the model and the data up to date, we try to best reflect the reality of the forecast. And that's why we also have the regional traffic forecasting group, where the regions are also involved in giving us feedback from what they observe, and that's also very important. Yes.
Well, thank you very much, Anthony, for your presentation.
Thank you to all of you.